how many bark beetles does it take to kill a tree? And the answer is it's incredibly variable. If the tree has been hit by lightning or it has a root fungus, a dozen or 2 dozen beetles can kill it. But if a tree is healthy and it's got all the water that it needs, there are cases, documented cases, where 2,000 beetles will hit a tree. All of them get pitched out, and the tree survives the entire attack. And so a tree that can be susceptible 1 month after a nice bout of rain can be resistant the next month. And most people will tell you that no tree is truly, truly resistant. If 3,000 beetles hit it, then it succumbs. So it's just a matter of how many beetles does it take to drop the oleoresin pressure to 0. Foresters found a rather simple mechanism for collecting bark beetles and surveying bark beetles. And this is called a Lindgren trap. And it's a series of funnels. You can buy them with 7 funnels or 12 or whatever. And these are collapsible, so they store really nicely. They hang down like this, and then you have the trap here. The most important part of there's 2 important parts. One part is up there in the plastic bag is a device that releases the pheromone, and it's good for about 120 days. And so that pheromone is the pheromone that gathers bark beetles to help kill a tree is pulling bark beetles into this general area. They come in, and bark beetles are looking for a columnar structure, dark, vertical. And so who knows whether they're going toward the tree and they hit this, or whether they're coming here because of that lure, or going to that tree because of the lure that we have up on it. But they'll hit this, they get knocked down in here, and they simply tumble, 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 tumble. And then we have a solution that's about 50% ethanol here. They tumble into there, and then they die shortly thereafter. Last year we were doing this just with these dry. You don't have to have anything in there. They're not able to get out. But the red-bellied clarid, their predator, was following them because it uses the same chemical clues to find them. So there's several species cluing in on this aggregation pheromone, and the predator would go in there, and I would empty this trap and find 4 or 5 predators and then fragments of beetles. It was like grape nuts in there, and it was just I had no idea how many beetles there had been in there, and the clarids had just been eating for several days. So this year we're doing it with it's called the wet option, and so it gives us a nice record of who's gone in there, because now everybody that goes in there gets killed. Some people have asked, well, if you can manufacture the aggregation pheromone, why don't you just put out these traps, collect the beetles, that way they can't hit trees, and then you can stop the epidemic that way. And the answer is, no, you really can't, because the epidemic, first of all, is so widespread geographically. It goes for miles and miles and miles, literally from here to the Yukon territories. But furthermore, just in this stand, if we had some mechanism for detecting bark beetles and we could ask how many are about today, there's probably 300 to 2,000 beetles around. And we're going to capture, we just picked 6 out of here. So we're picking up some of them. But in fact, this tree has been hit in the last couple of hours, and the previous tree was hit in the last couple of hours. So they may not come to this trap. The wind blows that pheromone around a little bit, and that pheromone may bring in beetles that then hit a tree over there or this tree. And they're not so, because there's turbulence and everything, the beetles only come to this general area, and then they choose something. One of the things that we've found that is most surprising to everyone who knows the bark beetles is that the bark beetle life cycle has really changed. The people who worked with it 1 and 2 decades, 2, 3, and 4 decades ago will tell you that the bark beetles started coming out in July. There was a pulse of them the second and the third week in August. They get out of the tree, they fly around for perhaps a few hours. Within a day, they're attacking a tree and beginning a gallery. That was done in August, and their offspring would get out of the tree the following year at about the same time, about 12 months. A female bark beetle can lay about 60 eggs. What Scott and I have found is that the bark beetles now are starting much, much earlier. This year, when did you catch the first beetles?
May 22nd.
May 22nd, instead of the first few coming out in July. And that's fully 2 months earlier. Furthermore, we catch them later. We catch them as late as September 20th. So the season is fully twice as long as it used to be. For those that get out early and can run through the gauntlet of predators, they can get to the trees in early June and start a brood. And we saw last year that the ones that can start early, their offspring are out in August, not 12 months later, 2 months later. As a consequence, a female that can start in June has 60 offspring, and then her offspring each have about 60. So that's 60 offspring plus 3,600 in a year. We think this is one of the reasons that this epidemic is unprecedented in scale and intensity. Instead, the reproductive potential is exponentially greater than it's been before, because now at least some of the beetles, we can't say that all of them are, but at least some of the beetles are pulling off 2 generations per year. So instead of 60, it's 60 squared. This is an example of their galleries. And so an adult last year came along here, and when she got to the right point, she put little divots in the side of that gallery and laid eggs in those. The eggs hatch, and the youngsters then go off in lateral bands from that. And there's a lateral band, there's a lateral band, there's one. And so they come off of these lateral bands. Each of them then builds a pupal chamber, stays in there for a little while, and then they come out as callow or teneral adults. And that's what these are right now. So these are brown. They'll be black very shortly. And if we hadn't pulled them out of here, they would be boring exit holes in this. And the exit holes would look exactly like the exit hole over here. Now, some people have asked, does drought or climate change have something to do with it? And the answer is, it certainly does. First of all, the climate change, and Scott has found statistical evidence to say that the temperature is particularly changing in spring, before July 1. That helps explain the early activity of the beetles. In addition, everyone has seen that midwinter temperatures aren't as cold as they used to be. Some foresters will say, well, then not as many larvae are frozen to death in the middle of winter. And because we don't have the winter mortality we used to, the bark beetle epidemic is worse. And I can't say that that's not important, but in my mind, I think that's probably minor, because when you look at the data on winter kill, you can find one tree that has 70% of the larvae killed, and the tree next to it, which was the same temperature, only 30% killed. The next tree over, 0% killed. So there is a lot of variability among trees, among broods, in how many die. I don't think winter temperature is that important. It may contribute a little bit. In my mind, the change in summer temperature is much more important. First of all, the season is much longer. The beetles are now starting in May instead of in July. Instead of one peak in August, there seems to be maybe a peak in June, and then there will certainly be a resurgence in August as well. In addition to the length of the flight season, the trees are under a greater drought stress. I think it gets warmer and drier during the summers now, and the growing season is longer. So the trees have to be active for a longer time with maybe less water during the summertime. The primary defense of this tree is dependent on how much water it can pull out of the ground. And so if it's hotter and drier, this is a more susceptible tree. So then instead of perhaps 800 beetles needed to kill this tree, perhaps only 200 are needed to kill it. If it gets really drought stressed, a couple dozen can kill it. And so the hotter and drier the trees are, the more crowded they are, the windier the conditions are when it's really hot and dry. These things all help the beetle by making the tree more susceptible. And so I think the life cycle is changing to 2 generations per year. And then in addition, the trees during the summertime are more susceptible than they used to be. The tree needs water for everything. It helps drive photosynthesis. It's needed for respiration, and a tree respires just like we do. They release carbon dioxide. That process needs water. But one of the primary uses of the water, and certainly the primary defense, is that the water is turned into resin. And the resin is stored in resin canals in the bark, and that is what the bark beetle severs when it goes tunneling into the tree. That's why resin comes out. And if the tree is beautifully healthy, an enormous flow of resin will actually push it out. That's why foresters say it's being pitched out. It's pitch tossing the beetle out. It will toss them out, and if it dries just right, we can find bark beetles that have become encased in the resin. So that's the defense of the tree. If it doesn't have enough water, the resin pressure goes down. It can only put out a little bit of resin. The beetle has no problem with that, and the beetle calls in more and more, and they collectively sense when the oleoresin pressure goes to 0, and then they say, we've won. That usually takes just a few days on a mass attack. Perhaps one day, perhaps a few days.